Hi, welcome to the statics tutorials. So in this problem, we also have two vectors and we have a resultant, but in this case, the resultant is specified. So we're given that the resultant of the two vectors has a magnitude of 13.1 pounds, and then we're given the direction of the resultant. The resultant is going in the negative x direction, and we're asked not to find the resultant, but to find one of the two vectors that adds up to the resultant. And we've got our angle specified differently with our one force. So let's take a look at how to solve this problem, also using the triangle method. So with this problem, we have this 25.7 pounds, but instead of being given an angle, we're given a similar triangle on this. So this means that this vector goes in the same direction as this 3, 4, 5 right triangle. And you'll see a lot of these 3, 4, 5 problems throughout statics, pretty much with any textbook that you look at. So we're going to calculate this angle theta. So this angle theta is going to be the same as this angle theta for this small triangle, and that would be the inverse tangent, or the arc tangent of this side, the 4, over the 3 side. Remember, the tangent is always the side that's opposite over the adjacent leg. So that angle phi here will be inverse tangent of 4 over 3, and we'll get 53.1 degrees for that. Now we can go ahead and draw our triangle diagram. So I started out with the 25.7 pound vector. You could pick either one of these. This one just seemed easier since we knew everything about it. So I've got it going out here at that angle of 53.1 degrees. And then I know that my resultant is going to start at, remember, the same location as your first vector. And my resultant's coming out here along the negative x direction, and that's its magnitude, 13.1 pounds. And then I can see that F is going to have to now angle back slightly to meet that vector. So the F that I was shown in my original diagram, the magnitude may be about correct, but the angle here is definitely not correct. It's going to be actually going back in the positive x, negative y direction. So I've got my triangle drawn, and I know this side, I know the angle, and then I know this side. So I can again apply law of cosines. Here's the law of cosines triangle and the law of cosines formula to calculate F. So F is going to be equal to the two sides that we know, square them, add them together, minus 2 times the two sides that we know, times cosine of the angle between those two sides. So that's cosine of 53.1 degrees, and then you take the square root of all that, and when you're done you get the 20.7 pounds. So that's our magnitude now for F. Now we just have to find its direction. So going back here, we can calculate this angle B, which would be the angle from the x-axis to this portion of F. We can do that with law of sines. So we'll say that the 25.7 pounds divided by sine of B is equal to the side F, 20.7 pounds, divided by sine of the 53.1 that's opposite F. And we can rearrange this and solve for B, and then we'll get that B is 83.6 degrees. But when we look at this, we can see that, well, B is actually going to be greater than 90 degrees. So remember that sine gives you two or more values that have the same result. So we can do 180 minus 83.6 and get 96.4, and check that in your calculators, and you'll see that 96.4, when you take the sine, gives you the same result as taking the sine of 83.6. So we need to go with this bigger angle. Always be careful of that when you're using law of sines and law of cosines. You have to kind of figure out the direction and whether your angle is going to be greater or less than 90 degrees just based on your diagram. Then we want to be able to write this force in that same magnitude and direction format. So drawing this force F here, if we move it down so it's coming down below the x-axis, we have this angle that's measured to this kind of extension line going out, We want this other angle so that we have the angle that's measured clockwise from the x-axis. So that would be 180 minus 96.4. And that gives us that same 83.6 back here. And so our force is then going to be a magnitude, 20.7 pounds. And then we'll draw our direction. So we'll draw our x-axis. We'll draw our vector below the x-axis. And then we'll draw in the angle to the vector. And then we'll say that's our 83.6 pounds. Thanks for watching.